All right, so now I just want to review a little bit of our writing and balancing chemical equations and then what types. And basically all I did was I did a search on the internet, writing and balancing chemical formulas or chemical equations worksheet, and I found a worksheet. And so hopefully this www.sciencegeek.net doesn't mind that I go ahead and just practice and show a couple of examples with this. So let's go ahead and do that. Now notice we see some word equations, and again the real key to being able to write and balance equations is to be able to write the correct formulas for the words. And so if you take a look at this first one here, sulfur and oxygen, sulfur plus oxygen, arrow, sulfur dioxide, which again could be the word equation, would be sulfur reacts with oxygen to produce sulfur dioxide, whatever it might be. But let's go ahead and take a look at writing and balancing this equation. Sulfur, S, with oxygen. Now notice oxygen needs to be O2. Why? Because oxygen is a diatomic. Sulfur is not, so I can keep it as just S. To produce sulfur dioxide, well, there you go, SO2, and it is balanced already. Let's take a look at this next one. Now, zinc is something that can be alone, reacts with sulfuric acid. Well, sulfuric acid is H2SO4. Again, you would need to know that, how to write acids, but so there you are. To produce zinc sulfate, well, I'm not really happy with this one in the case that zinc's in the middle. Zinc can change. It could be a +1 or it could be a +2. There really should be a Roman numeral. For our purpose today here, why don't we go ahead and call it 2, just so we have to balance a little bit. So zinc 2 sulfate. Zinc 2 sulfate, zinc 2 means it's a 2+, sulfate is a 2-, so it would be just ZnSO4, and hydrogen. Remember that hydrogen is also diatomic. It would never be alone when it's alone. So now let's balance. 1 zinc, 1 zinc. 2 hydrogens, 1 S, 1 S. There you go. So I'm balanced. How about this next one? Hydrogen and nitrogen to produce ammonia. Ammonia is NH3. Now we're going to have to do some balancing here. 2 hydrogens, 3 hydrogens. I should put, let me go ahead and grab a different color here, a 3 in front of that and a 2 in front of there to make it 6, so that's the least common on both sides. And notice now I have 2 nitrogens, and I am balanced. So those are all pretty simple. Let me erase this real quick, and let's just kind of kill 2 birds with 1 stone and take a look at the types. Okay, this type, right, well, let's, I think the red will be enough here. This would be a direct combination, because again we only have the one product. This would be a single replacement reaction, single replacement because we have only the one alone and it's replacing, getting together with the sulfur, sulfate, and then the H is alone, so single replacement. And this one is also direct or synthesis, direct combination or synthesis. Okay, let's take a look at scrolling down here and see if we have some other ones that might include some different types of reactions. So we'll scroll down here. All right, number 9 certainly is an example of a different type of reaction. Let's go ahead and do this one. Barium chloride. Again, before you just write down barium chloride, you need to see how it balances. So barium is a 2+ charge. Chlorine, when it forms its ion, is a -1. So barium chloride is going to be BaCl2. Okay, you got to write the correct formula first. Sulfuric acid, that's the H with the SO4. Again, 1 positive for the hydrogen, 2 negative for the sulfate. So sulfuric acid is H2SO4. Now I'm telling you the 2 products here, but if I cross them out, you should be able to tell what they are. You should be able to determine what the products are by looking at what type you think it is. I look at it and I see the positive and negative and the positive and negative. This is going to be a double replacement reaction. The barium will get together with the sulfate. The plus will want to get together with the minus, the cation with the anion. So you'd get barium sulfate. Notice that 2 plus, 2 minus, we just need one of each. And H with the Cl, we always write our cation first, HCl. Now if I erase what I had crossed out, notice that barium sulfate, that's indeed what this is, and hydrochloric acid. Okay, let's balance it. 1 barium, 2 chlorines, 1 chlorine, let's go ahead and put a 2 there. 2 hydrogens, 1 sulfur, 4 oxygens, and unbalanced. So this is a double replacement reaction. Okay, let's scroll here just a little bit and do another one. This is an example here. Ethane, C2H6, reacts with oxygen to produce carbon dioxide and water. First of all, before I even mess around balancing it, I should know that this is a combustion reaction because I see carbon dioxide and water, and it's a hydrocarbon reacting with oxygen to produce that, so combustion reaction. Now let's balance. 2 carbons, 1 carbon, let's put a 2. 6 hydrogens, now 6 hydrogens. 2 oxygens, here there's 4 and 3 more, so that's 7. Now here's a little tip when you're doing combustion. This happens with combustion reactions a lot. And I'll be curious to see on worksheets and quizzes who actually watch this video, because here's the tip. We've got 7 oxygens on this side. There is no coefficient that I can put in front of that 2 of oxygen to make it ever odd. Okay, there's nothing I can put. No matter if I put an even or an odd, it's always going to be multiplied by the 2, and so you can never get an odd number. So here's how you do that, and it happens with combustion reactions. You basically double the ones besides the oxygen, double the other ones, and by doubling all of them, then they'll all still be balanced. So if I put a 2 here, that means I have 4. I double this one, which means I have 4, and I double this one, which means I have 6. Notice that I've doubled this to 6, doubled this one to 4, and I doubled this one to 2. By doing that, my carbons and hydrogens are still balanced, and now I have 8 and 6 more is 14. I can put that 7 in front, and I have a balanced equation. Okay, and again, it's a little bit messy here. Let me clean this up. But we had 6 and 4 and 2, and there's your balanced equation. It's a nice little tip to knowing how to balance a combustion reaction. So those were some examples. You know, it's very easy, and I'm sure you can simply do like I did and type in types of chemical reactions, and here's a types of chemical reactions, and I found this on the Dearborn schools, again, just a worksheet. We could simply go through this first one where the sulfur dioxide and oxygen react to produce only one product. Well, that's going to be direct combination. Notice it says synthesis. We could call them either. This next one, what type do you think it is? Well, we've got a aluminum getting together with the hydroxide, and then the calcium getting together with the sulfate. This is a double replacement. This next one, once you see the carbon dioxide and water with the oxygen, this is a combustion reaction. 4, notice it's alone, and notice that it replaces and gets together with the nitrate, magnesium does, and silver is alone, so this is going to be a single replacement. How about this next one? Well, I can tell pretty quickly by looking at it. We've got a cation and anion, cation and anion. I bet you the barium goes together with the phosphate, the hydrogen gets together with the nitrate, and that's exactly what happens. This will be a double replacement. And let's see if there's any of the other type. Oh, yeah, the next ones are our other types here. Notice that we have one reactant breaking down into 2 or more products. So this is going to be a decomposition, and so on and so forth. You can find all these different examples, worksheets right on the web if you want to practice some extra types or reactions or balancing. Again, this was from the Dearborn schools. Notice that they actually, I think, no, maybe not on this one, but they usually have the answers as well. But there's an examples. There's a couple extra practice problems. Hopefully that helps you.